Alright, we're back for another round with my videos. Hopefully it helps out a little bit better just having it in my words for what I want at least. But hopefully it did help last week. So this week we're moving on with 3x3 systems. Still systems of equations, obviously. We just got 3 variables, 3 equations. We're going to have the survey that's going to be coming out every week. That'll be an easy 5 points for you. You just do it and you got 5 points for the week. And the worksheet we're going to have as well. So just the survey and a worksheet. That's about it. That'll be for the most part what we have moving forward as well. Last week was a little bit extra just with a couple surveys pretty much. But yeah. Here I got the systems or the steps for you for the systems. So step number 1, we're going to pick any pair of equations from the system and we're going to eliminate one variable. It doesn't matter what variable, you take the pick. There's usually one that sticks out. Step 2, you're going to pick a different pair of equations and eliminate the same variable as you picked in the first step. So the first step sets the tone for the rest of the problem. What happens when you eliminate one variable out of the 3 from one of the pairs, you're left with a system of 2 equations. So what we did the past couple weeks, 2x2 systems, 2 equations, 2 variables. You solve that system. You find those 2 variables, take those, plug it into the original 3 and find the third variable. That's pretty much it stepwise. I have 3 examples I'm going to talk through. That'll be about it. So, first one. We got our system. We got 3 equations. I personally number these. I number them for hopefully better note-taking purposes, better organization as well. It's up to you if you want to do that. I do that with or without these videos. I feel a little bit better organized when I do that with it. So, looking at my 3 equations that I have, I'm looking here right in the middle, my y's. If I add together 1 and 2, as you can kind of see, I'm going to choose, the y's cancel. Then if I add together 1 and 3, the y's are going to cancel again. You get a positive 4y and negative 4y in each of those. For the most part, you'll have one variable that's pretty easy to cancel out. So when I add together 1 and 2, I just add straight down. 4x plus 2x, I get 6x. The y's cancel like I said they would. Z plus z is 2z, 24 plus 0 is just 24. I do the same thing with 1 and 3. Now I'm not rewriting these equations. You can if you want. It's kind of up to you. I normally don't when I do my notes and all that. So 1 and 3, 4x plus 5x, get 9x. Y's are gone. I have negative 4z and a 36 after that. So I have a 2x2 system. I try and cancel out x or z at this point. It's up to you. You can use substitution. I typically think elimination is easier, combination, whatever you want to call it. I think the z's are going to be easiest to cancel. So in order to do that, I need to multiply the first equation by 2. So I do that. I get my resulting set here. I add straight down. The z's cancel. We get 21x equals 84. Divide, I get x equals 4. Now I got to plug 4 in for x, since that's what x equals. In equations 1 and 2, in this top one or this bottom one. It doesn't matter which one, you just kind of pick. I'm going to pick the first one. Number 1, it's smaller numbers. Number 2, the z is positive, and I like dealing with that. So I'm going to go ahead and plug it into 1 and 2 for x. Show whatever work you need to there. You can see pretty basic steps happening. Whoops. Now we get negative 24. Subtract 24, we get 0, and that's okay. Z just equals 0, so we got that. Now we move down here. Take my x and z and plug it into one of the original 3 to find y. I'm personally picking 1 because my y is positive. I like dealing with that. 2's not too bad either. It's just a matter of what you want to pick. So we're going to plug 4 in for x and 0 in for z in one of the original 3 equations to find y. Like I said, I picked 1 just because my y was positive. My only reason there. Do whatever work you need to show from that. Y equals 2 in the end. Now, I preferred to see my answers as ordered pairs in the first set of systems, the 2x2s. I want to see my answers as an ordered triple, please. So my x comes first, y is second, z comes last. So it would be 4, 2, then 0 respectively for x, y, and z. So this is kind of it in one view. A lot going on there. Hopefully the arrows kind of can put you in the right direction. It's kind of hard to truly organize this workout, but hopefully the arrows help. Not sure if they will or not, but we'll see. Next one. Similar deal here. If you're looking, we're going to need to tweak some things with this. Now, at a glance, I personally look at variables that can cancel out without changing anything. So you can see my 1 and 3 I'm going to add, and the z's cancel out. So my z's are going to cancel. When I do that, I get x minus 7y equals negative 20. Alright, so I got that. Now I have to cancel out z again. I can add together 1 and 2, or 2 and 3 if I want. 1 and 2 is just easier. Alright, the signs are already opposite, so all I need to do is change the second equation. So I need to multiply the second equation by 2 in order to cancel out the z's again. So a little bit of side work there, kind of expand that a little bit. I multiply the second equation by 2. This is my new second equation. Notice I put a new 2 there. I'm not going to renumber that because it's technically the same equation. So I add together this 2 with this 1. I get 12x minus 2y equals 6. Okay? Now I try and cancel out x or y. It doesn't matter. I like x because I only need to multiply the top equation by something, and that something is negative 12. So I do that. Get my resulting equations there. Add straight down. I deal some bigger numbers just for a moment. 82y equals 246. Divide. We get real small real quick. We get y equals 3. I take that 3. I plug it into one of these. 1 and 3 or 1 in the new 2. I chose the first one because x is by itself. It's positive. It's pretty easy to deal with. So I plug 3 into that. Just add 21 to both sides. Once you figure that out, just x equals 1. I have 2 out of the 3 answers I need. 1 and 3. Alright, if we have that, I take those, I plug it into one of the original 3 to find z. Doesn't matter which one, you just pick. I'm picking 1. Again, only reasoning is because my z is positive. Alright, my only reason. It's up to you. Doesn't matter. Plug it in, do the little bit of work that you may need to show to find that z equals 1. Write your answer as an ordered triple, please. If I can get them all in view, I got x is 1, y is 3, z is 1. So my ordered triple is 1, 3, 1. So that's number 2. Not much different than the last one, just that little tweak in the beginning, right, to multiply one of the original 3 equations by something. Now, 3 throws us off a little bit. It's a lot less going on, smaller numbers all throughout, so it's pretty nice. I look at this, my third equation is already missing a y. That is actually beneficial to us. So I want to cancel out the y moving forward. I'm going to use 3. I don't need to add it to something. It's already missing a variable. Alright, that's kind of what I'm pointing out here. Notice 3 is already missing a y, so I will use that one and try to cancel out y between equations 1 and 2 after that. But it adds straight down 3x plus 2z equals 5. Solve the system. This one honestly doesn't matter. You're multiplying probably the first equation by something regardless. I chose to cancel out the z's. You could have multiplied by just a -1 to cancel out the x's. It does not matter. Alright, work ends up being, or answers end up being the same, I should say, not necessarily the work. So I get this result, add straight down, I get 9x equals -9, so x equals -1. Take that, plug it into one of the original two. Again, I personally like dealing with positive numbers as much as possible, so when I'm looking at z, I know z is solo here on the first one, but it is negative. So I plugged it into the third one, or third equation there, because my z is positive. Do my little bit of work, get z equals 4. Keep going. Plug x and z in to find y. This first equation is best. You obviously can't use equation 3, so you had to pick between 1 and 2. 1, I think, is the obvious choice in this case. You just plug it in. I'm showing a little bit of extra work as usual in my notes. I find out y equals 3, so my triple is -1, 3, and 4. So those are my 3 examples I have for you guys. I am going to include 2 more examples that I've used in years past. They probably won't be as clear stepwise, but they're just something you can look at, that's all. But I do have 3 examples. The worksheet's only going to mirror problems 1, 2, and 3. I am going to provide the answers, just the ordered triple on the worksheet, so you can kind of work towards that. But obviously I need to see the work in order to receive full credit on the worksheet. But as always, reach out if you guys have questions. Other than that, we're good to go. Good luck this week, and hope you guys are all doing well. Alright, see ya.